All right, let's start talking a little bit more specifically about how heat is involved in our chemical reactions. Okay, so let's apply these terms, system and surroundings, to our chemical reactions. Now, the system, by definition, is the specific part of the universe that contains the reaction or process you wish to study. So if we're doing an actual chemical reaction, the system is going to be the reaction itself. And the surroundings are everything else outside of that system, outside of that reaction. So it could be us, ourselves, it could be our lab tables, our kitchen counters, it could be the glassware that the reaction is taking place in, okay? Anything that's not the actual reaction is the surroundings. So when we're talking about heat transfer, again, that's the heat flow going from the warmer object to the cooler object. And we have two terms that we use specifically in regards to chemical processes. And that's going to be endothermic and exothermic. Now, endothermic reactions, endo, that prefix means into. So endothermic reactions, the heat is going into the system. So when you look at this picture down here, you can see that here's the surroundings, this yellow circle. The heat is going into the system. Because the heat's going into the system, our Q is going to be greater than 1. It's going to be positive. So I did hint about that positive and negative Q in one of the other videos. So if Q is positive, that means heat is being absorbed. Now, exothermic, that prefix exo means exiting, leaving. So an exothermic process is when the system loses heat to the surroundings. So when you look at this picture here, again, the yellow is representing the surroundings. The heat goes from the system out into the surroundings. So remember, we are the surroundings. What we feel is the surroundings. So with endothermic reactions, what we feel is going to be the surroundings getting cooler because the heat is leaving the surroundings and going into the system. So since we're feeling the surroundings get cooler because it's losing heat. With exothermic reactions, remember the heat is exiting the system into the surroundings. We're feeling the surroundings, so we would feel hot and the surroundings getting warmer as the heat escapes the reaction itself. So let's take a look at some examples here and determine if it's going to be endo or exo. And I did suggest drawing the phase change diagram to help us visualize what's taking place here. So let me move this little thing right here. So here was our, can we see this red? Let me make it white. Our little phase change, crude little drawing here. Remember, this was energy down here, and this was temperature on the y-axis. This might help us a little bit as we take a look at these. So when we're talking about evaporating alcohol, evaporating means it's going from a liquid into a gas. So when we look at our phase change diagram, we're going this way right here from our liquid into our gas. Looking at this energy line, we can see that we need energy in order to get that to happen. So this reaction, evaporating alcohol, would have to be endothermic in order to absorb the energy and weaken those intermolecular forces of the liquid. Leaves burning. When we see the word burning, what do we picture in our head? We picture fire. So this is definitely going to be an exothermic reaction. Sorry. Boiling water. So when we think about boiling water, maybe spaghetti is your favorite dinner like my son's, we would put a pot of water on the stove. We have to crank up that heat. So we're having to give it heat in order to get it to boil. So that's also going to be an endothermic reaction. Water cooling. So when something is cooling, that means it's losing heat. So that has to be an exothermic process. Melting ice. When you look at your phase change diagram up here, melting ice, ice is a solid, going into a liquid form. So that's going this way on our phase change diagram. So again, that's going to be endothermic because it has to take in heat to go that way. And then freezing water, when we look at our energy diagram up here, freezing water means that we're going this way on our phase change diagram. So this one has to be exothermic because it has to lose energy to go down in that direction on the left side. Okay. So endo versus exo again. So with endothermic reactions, you would see heat as a reactant. So when you look at this example reaction up here, you can see that heat is on the reactant side. That's telling us that this needs heat in order to go. And our Q, our heat, is going to be positive because it's absorbing heat. Exothermic reactions, heat's going to be a product. So when you look at a sample reaction like up here, you'll see heat on the product side telling us that it is releasing heat and producing heat as a result of the reaction. Because it's releasing heat, our Q would be negative. So that's another way of telling if it's an endothermic or an exothermic reaction.